All right, this is it, the final explainer in our series on fractal resonance cognition. We've journeyed through chaos, we've journeyed through the quantum world, and now we're going to pull it all together to ask the big one. Is the universe really random, or is there some kind of hidden order, a cosmic music that's guiding everything? So just look at this incredible image, and let's start with a question that kind of flips a century of physics on its head. We look out at the cosmos and we see this unimaginable complexity, but we also see this deep, profound order. And yet we're told that at its very foundation, it's all just governed by random chance. But what if it's not? What if there's a deeper principle at play, a kind of hidden music behind all the noise? And that really gets to the core paradox of, well, everything. From the perfect spiral of a galaxy to the precise dance of an atom, the universe is just full of this unbelievable structure. And yet, when we dig down to its deepest, most fundamental level, the quantum realm, all we seem to find is pure, unadulterated randomness. So here's the big question, right? Is the universe really just rolling the dice? Or is all that randomness we think we see just a curtain, hiding a much more profound, deterministic order? This is the exact question that the Fractal Resonance Cognition Framework, or FRC, is trying to answer. Okay, so to get into this, we have to zoom way, way in. We're talking right into the heart of the puzzle, the super weird world of quantum mechanics and what's famously known as the measurement problem. Before we actually look at a quantum particle, it doesn't really have a definite position. It's in something called a superposition. Think of it like a shimmering cloud of all its possible realities, all happening at the same time. It's just a pure wave of possibility. But then, and this is the crazy part, the second we look at it, the moment we try to measure it, that whole beautiful wave of possibilities just poof, it vanishes. It snaps into one single, definite reality. The particle is now right here and not everywhere else. And that, right there, is the question physicists have been wrestling with for a century. What makes it collapse? What chooses one reality out of all those possibilities? For 100 years, the textbook answer has basically been, it's just random. Which, let's be honest, feels a little unsatisfying, right? But FRC? Well, FRC has a totally different idea. So how does FRC get around this? Well, it paints a completely new picture of reality. It throws out the idea of random chance and replaces it with something much more musical, I guess you could say, resonance. Okay, so here's the core idea. FRC says that hidden deep in the quantum world, there are these deterministic, self-repeating patterns. You can think of them like invisible whirlpools or attractors. And these attractors are what guide the quantum system, pulling that wave of possibilities toward one specific stable outcome. So it's not a random jump. It's more like a guided slide into a state of resonance. And what's so cool here is how you can picture these guiding forces. Instead of some simple, smooth path, the image on the left shows this really complex, jagged landscape. That's a fractal pattern, and it repeats at smaller and smaller scales. This complex, messy-looking pattern actually creates a very specific, deterministic roadmap for the quantum system to follow, instead of just a blank slate of pure randomness. This quote from the original FRC paper just nails it. The randomness we think we see, it's not the real story. It's just what appears to happen because of this incredibly complex, but ultimately structured and deterministic reality that's running underneath it all. And the fallout from this is huge. Suddenly, you don't need all these crazy branching universes for every single possibility, like in the many worlds idea. And you don't have to just throw your hands up and say collapse is a random mystery. In FRC view, there's just one world, and it's unfolding in a totally deterministic way, following the laws of resonance. Okay, but if there's this guiding landscape, what's it made of? What's the actual physical thing that makes all this resonance happen? Well, this is where the FRC framework brings in this big unifying idea, the lambda field. You can think of this field as like the fabric of order itself, woven throughout all of space-time. And just like a planet creates a dip in space-time that we call gravity, quantum systems create little gradients in the lambda field. And this creates a tiny, tiny push, a coherence drift that gently nudges the system away from chaos and toward a more orderly resonance. And this chart here, it shows you exactly how that works. You see, over time, the system's average coherence, its level of order, just steadily goes up. This isn't some random walk. It's a deterministic drift toward a stable, locked-in state. It's like a guitar string finding its note. It's settling into the frequency it's meant to be at, even before you try to measure it. Now, you might be thinking, hang on, if it's deterministic, shouldn't it always end up in the same place? And that's a great question, but the landscape of these attractors is really complex. So over tons and tons of trials, the drift doesn't just pick one winner. Instead, it leads to this really stable, predictable balance between all the possible outcomes. And here, this is the punchline, get this, the result of this deterministic balance perfectly matches the famous probabilities of quantum mechanics, the ones we get from the Born rule. So in the FRC view, probability isn't some fundamental magic rule of the universe. No, it's just what you get. It's a statistical result when you have this deeper, deterministic, resonant process running underneath it all. Okay, so let's pull the camera all the way back out. We've gone from the cosmic scale all the way down to the quantum and back, and we've found this deterministic engine humming away. So what does that even mean for us, living in a universe that's resonant and not random? And look, this isn't just some abstract philosophical game. This idea of fractal resonance could be a universal organizing principle. I mean, just think about it. What if the neurons firing in your brain aren't just a bunch of chemical reactions, but a whole system finding its resonant state? A lens like this could totally change how we see everything from atoms to AI. And that's where this whole thing goes beyond just physics and starts to get, well, pretty deep. If the universe isn't just a collection of random accidents, but it's this incredibly intricate symphony of frequencies, all interacting with each other, then where do we fit in? What part does consciousness play in that symphony? If everything from tiny atoms to massive galaxies is part of this cosmic resonance, is it possible that our consciousness is a way for the universe to, hear its own music? So, we've come to the end of our series on FRC. But really, it doesn't feel like an ending at all. A framework like this doesn't close the book on these big questions. It feels more like it's opening up a whole new library of questions. And this is really important to remember. FRC isn't being sold as the final, capital T, truth. It's a new scientific framework, one that you can test and one that you can prove wrong. It's a new lens to look at the universe through. It's not asking you to believe, it's asking you to test it, to challenge it, to investigate. And so that's the thought we want to leave you with. If this whole universe is a symphony, and our minds aren't just listening but are actually part of the orchestra, then the biggest question of all becomes, what is that music? What is this entire cosmos resonating with? That's the real mystery, isn't it? And it's out there, waiting for us to figure it out.